Hi folks, this is Dr. Rob Cywes, and today's going to be a very interesting discussion because as much focus as there has been on what fuel is ideal for the human body, even the people that are very enlightened and study this tremendously, who I have common conversations with, I don't think understand this particular fuel source as being the most dominant fuel source of the human body. There was a paper that was published in 2015 looking at the fuel sources of the heart. Now, the heart is the most active muscle in the human body. Contrary to popular belief, the brain is not a muscle. So, what fuel sources does the human body use? And there really are only three fuel sources. There is sugar, glucose. There is protein, amino acids. And then there's a fairly complex group of things called fats, and we're going to explore that. So there are certain cells in our body that have to use amino acids. For example, the intestine, a large number of the enterocytes, the intestinal cells themselves, use an amino acid called glutamine and other amino acids as their primary fuel source. So they're able to extract energy directly from amino acids. But there are not many cells in the body that can do that. Mostly the liver will convert amino acids to sugar or to fat. And we'll talk about that in another session. The second fuel source is sugar. And while sugar is not essential to be consumed as a fuel by mouth, because the liver is extremely good at manufacturing sugar from fat and from proteins and storing sugar that we do eat and releasing that slowly over time into the bloodstream, there are certain cells, for example, red blood cells and Schwann cells, the support cells for nerves and for nerve fibers, that are sugar obligate, that have to use sugar. And that's pretty obvious. And there are some people who are large carbohydrate eaters where insulin levels are up continuously, which blocks fat mobilization, and therefore they are glucogenic. They are in glucosis all the time, and there's harm that can occur to the human body if your body is purely dependent on sugar as a fuel source. But this is not about carbohydrates, diabetes, all that kind of stuff. Today I want to discuss fat. And here's what's really, really interesting. And as I've explored this, it's just there's question after question after question that arises in my brain. We obviously understand ketones as a fuel source. Ketones are 2 and 3 carbon structures that are the breakdown products, the building blocks of fats. And the liver is very, very effective at breaking fats down into ketones, releasing those into the bloodstream. We can measure those in the bloodstream using something like a Keto Mojo or a ketone monitor. And the majority of cells in the human body can use ketones as a fuel source. They can use ketones as a fuel source. And I think the mistake that we've made in the modern era is to think of two alternative fuel sources for the body, glucose or ketones. And that's false. That's wrong. That's incorrect. There's a third fuel source that most people don't even consider. And yet around 80 to 85% of the fuel that the heart uses, that the heart depends on to beat, because the heart doesn't store fuel, is this particular fuel source. Yeah, it uses a little bit of sugar, a little bit of ketones, a little bit of lactate that it'll repurpose. So lactate is a minor fuel source, not a major one. But the primary fuel source is free fatty acids. What the hell is a free fatty acid? Whoa, hold your horses here. What's a free fatty acid? Well, when we look at the lipids in the bloodstream, you've got ketones, we've spoken about them. We've certainly got the large globular complex molecules called the lipoproteins, which are LDL, IDL, VLDL, chylomicrons, HDL. Those are transport barges or transport molecules for fat around the body. We know those two. The hell is free fatty acids? We also know that triglycerides, complex of 3 fatty acids connected by glycerol, can be connected if they're short chain or not short, but if they're relatively short long chain fatty acids, they can float freely in the bloodstream connected to globulin and certain transport proteins like albumin, and they can be transported back and forth from the fat cells to the liver and back and forth. But those are primarily, the lipoproteins are primarily for transport of fat to and from the liver and the fat cells, for production into ketones and also for structural proteins, phospholipids, that kind of thing. But that isn't the dominant fuel source for a ketogenic human being. And even a non-ketogenic human being. The primary fuel source, the largest amount of fuel, is the unspoken one, free fatty acids. So what's a free fatty acid? Well, when you look at fat, it's a long chain of carbon molecules. The long chain starting at about 16 to 18 carbons. In fact, 16 is palmitic acid, which is the conversion of sugar to fat. And then they get conjugated into triglycerides with a glycerol backbone, 3 of those with glycerol. But those fatty acids can be released and are released free from the fat cells. And they float in the bloodstream combined with a protein called albumin. And those free fatty acids go to almost all of the cells in the body, except maybe for the brain, because they don't cross the blood-brain barrier very readily. Mostly ketones do that, and that's possibly why we've gotten off on ketones. But free fatty acids are taken up by all cells in the human body and very readily converted to fuel. 80 to 85% of the fuel that the heart uses to beat comes from free fatty acids. And what's interesting is those free fatty acids are released by fat cells directly into the blood. Other organs aren't really involved in the manufacture of those free fatty acids. And the free fatty acids can be monosaturated, polyunsaturated, or saturated. What do those 3 words mean? It means the double bonds. If you've got 2 carbon molecules, sometimes they're linked with what's called a double bond, and that is an unsaturated molecule. Saturated means there's only one bond between the carbon structures throughout the fat. Monounsaturated fats have a single double bond in the entire thing. Saturated fat has no double bonds, whereas polyunsaturated fat have multiple double bonds. What's the danger there? The danger is that when those double bonds break, whether they're in a cell membrane or they break in a mitochondrion or inside the cell, they release oxygen-free radicals. And it's those reactive oxygen species that promote inflammation, that promote the immune system attacking the body, hyperactivate the immune system. You've heard of antioxidants and all the things that they love to give us for antioxidants. Those are designed to mop up or stabilize or get rid of those reactive oxygen species. So the polyunsaturated fats can be very, very toxic, including the 6 omega fatty acids, which is the focus of polyunsaturated fatty acids being harmful to the body. Even those 6 omega fatty acids, linoleic acid, is essential to the human body. We can't produce it inside. When it does get metabolized, it produces pro-inflammatory molecules, arachidonic acid, some of the eicosanoids. But be that as it may, free fatty acids are the primary fuel source of the human body. At this stage, I don't know what the role of free fatty acids are in someone who is in high insulin glucosis, in hyperinsulinemic glucosis. I believe, but I don't have evidence of this, that those free fatty acids cannot be released from the cells, and that may contribute to fatigue, may contribute to a lack of energy, particularly if you've been physically active for a while because you run out of sugar. And if you're not replenishing sugar very quickly, those high levels of insulin block the use of those fatty acids. Certainly they block ketosis. But free fatty acids are liberated or released from fat cells directly, or while the lipoproteins are unpacking their lipid load into the fat cells, some of that free fatty acids spill out into the bloodstream. But it's those free fatty acids that in local circuits are our fuel source. So here's the interesting thing. We never measure those in blood work. We don't need to measure them in blood work. But those free fatty acids travel from the fat cells to the next capillary system where they are taken out and used by those organs. So the fat cells liberate the very free fatty acids into the veins. Those veins go straight to the heart, to the lungs, where some of them are used, through the lungs to the heart, where a lot of it's used as well, and then distributed to the rest of the body, where in the capillary systems it's used. It never gets back to the liver. A very, very small fraction goes through the hepatic artery to the liver, but the liver never sees those free fatty acids. Interesting, huh? So that the free fatty acid energy complex functions free of the liver. And the liver is only there to provide sugar and ketones to the body in addition to those free fatty acids So a whole new realm of thinking that even the most brilliant minds haven't yet started to explore. That as I was doing research for writing actually a book chapter on the topic, this is the unspoken part of the world. And speaking to guys like Dave Feldman, they're only now starting to understand that local micro circulation. If you think of a big city, it's kind of like what happens within a suburb. You may have the big Costco or the big superstore warehouse that serves the whole city, but you might have the little mom and pop grocery store on the corner of every suburb. That's the way free fatty acids work. The liver works as this huge big thing that supplies energy to the whole city, which is your body. But the little small stores are the things that provide free fatty acids to the local environment. So another huge consideration, and a huge, in my belief, I'm going to prove this over time, but where low insulin levels are so important to the adequate release and production of those free fatty acids, and why having a low glucagon level is so important. Why is glucagon important? Because glucagon allows for those free fatty acids to be released from the cell. High insulin blocks the lipoprotein lipase and the hormone-specific lipases from releasing those free fatty acids. So you want an intact glucagon-insulin ratio to have the correct fuel supply for your body. This is such an important new frontier for understanding energy economics in the human body, and as yet very underexplored. We know ketones, we know glucoses, we know insulin, but understanding free fatty acids and their circulation and their value in the body is so important. But what have we done, folks? We've demonized fat as being this evil, especially saturated fat. We're all on statins because saturated fat is so bad for us. What the hell are we doing to our energy supply by the use of statins? We're destroying it, particularly if it's true that statins do not prevent cardiovascular disease. Hopefully I've made you think. If I have, leave some comments. But let's see what you know about free fatty acids as fuel sources. We've got glucose, we've got ketones, and we've got free fatty acids. And it's the free fatty acids that your body depends on the most. Not going to kill you. In fact, going to keep you alive fatigue-free. I hope this helps. I hope that you're able to leave a comment or two, hit the subscribe button, and throw a cup of coffee at us on our Patreon account. It helps to keep these videos free. See you next time. I am the Carb Addiction Doc.